Hello dear students, welcome to Cyber, the new session of class 10 physics, chapter the human eye and the colorful world. And today we are going to discuss about the scattering of light. Okay, so just listen here. You just imagine that there are a number of dust particles and water droplets, air molecules, everything in the atmosphere like this. Okay, just imagine it as an atmosphere. Okay, it consists of dust particles, water droplets and air molecules, something like that. And we know that the sunlight is a white light, right? Why? Why the sunlight is white light? Because the sunlight which consists of the 7 colors, violet, indigo, blue, green, yellow, orange, red. So, the sunlight is a white light in nature. When the sunlight enters the atmosphere, and this light heats the particles that are present in the atmosphere. The sunlight enters the atmosphere and heats this kind of particles that are present in the atmosphere and deviates its path or reflect in different directions. And this kind of reflections in the atmosphere due to the presence of the particles that are present in the atmosphere is called the scattering of light. It is the scattering of light. Once again, the sunlight that enters the atmosphere, and already the atmosphere consists of a number of dust particles, water droplets and air molecules. So when this light happens to hit on this kind of particles that are present in the atmosphere, the light reflected in random directions, and that is what we call scattering of light. Clear? Yes. And this scattering of light depends on the size of the particle. Scattering of light depends the size of the particles. And the first category, dust particles and water droplets. And the second one, air molecules. First one, dust particles and water droplets, then air molecules. So we just consider the first category, that is dust particles and water droplets. What is the importance of this dust particles and water droplets? The size of the water droplets and dust particles much larger than that of the wavelength range of the visible light. Once again, the size of the dust particles and the water droplets much larger than that of the wavelength range of the visible spectrum. We know that violet, indigo, blue, green, yellow, orange, red. This is what we call the visible spectrum, right? So among this we know that red color has the maximum wavelength and violet color has the minimum wavelength, right? Yes. In the spectrum, red color has the maximum wavelength and violet color has the minimum wavelength, right? So in the first case, the dust particles and water droplets, they have much larger size as compared to the wavelength range of the visible light. So in such cases, suppose you just imagine that, just imagine it as a water droplet, big one, okay. A sunlight happens to fall on this water droplet. So we know that the size of the water droplet is much larger than that of the wavelength range of the visible spectrum or the white light, right? So in this condition, the entire light reflects in the same way. Each and every color which reflects in the same way. So this scattered light also appears as white in nature. This is called scattered light. This one. Scattered light. second case, air molecules. These air molecules, they are smaller than that of the wavelength range of the visible spectrum. The air molecules, the size of the air molecules, much smaller than that of the wavelength range of the visible light. In such cases, the colors having lower wavelength, scattered in the atmosphere. But at the same time, the colors having higher wavelength, they do not scatter much. Clear? Because the air molecules, the size of the air molecules, much smaller than that of the wavelength range of the visible spectrum. Therefore, the colors having lower wavelength, like violet, indigo, blue, the colors having lower wavelength, they scatter in the atmosphere. At the same time, the colors having the higher wavelength, like red, orange, yellow, they do not scatter much in the atmosphere. Clear? Okay. So, very simply we can say that the scattering of sunlight, which depends on the size of the particles. The first one, dust particles and water droplets, and the second one is air molecules, because they are different in their size. Clear? Another important point is that Tyndall effect. Tyndall effect. What is Tyndall effect? What is Tyndall effect? Okay. The scattering of light by the particles that present in the atmosphere is called Tyndall effect. Once again, the scattering of light by the particles in its path is called Tyndall effect. Okay. So also a very important point, Tyndall effect. And some common examples are there for this Tyndall effect. For example, when the sunlight enters the room through the window, the path is visible to us. The path becomes visible to us. Why it is so? Because our room, which consists of the dust particles, when the sunlight enters the room, the beam of light happens to hit on all the particles that are present in the room. As a result, the light rays are scattering here and there, and this scattered light enters our eyes, and finally we are able to see the path of light. So, one example. Another example, the same Tyndall effect that we can observe in the canopy of a dense forest. In such case, the water droplets or the mist that present in the forest to scatter the light, and the same way we can see the path of the light in the canopy of a dense forest. That is also another example for Tyndall effect. Clear? Yes. So these are the general ideas. Once again I will say the scattering of light, which means different particles that present in the atmosphere, like water droplets, dust particles and air molecules. And when the sunlight enters the atmosphere, it hits this kind of particles that present in the atmosphere and reflects in random directions. That is called scattering of light. And this scattering of light depends on the size of the particles. And the first one, dust particles and water droplets. And these particles have much larger size as compared to the wavelength range of the visible light. So here we know that red color has the maximum wavelength and violet color has the minimum wavelength. So in the first case, all the colors reflects or deviate in the same way or scatter in the same way. Therefore, the scattered light also will be white in nature. Clear? At the same time, in the second case, the air molecules, they are much smaller than that of the wavelength range of the visible light. Therefore, the lower wavelength colors like violet, indigo, blue, these kind of colors scatter in the atmosphere. Clear? At the same time, the colors like red, orange, yellow, because these colors have maximum wavelength or the higher wavelength, they do not scatter much in the atmosphere. Clear? So these are the ideas. Then finally Tyndall effect. Tyndall effect means it is the scattering of light by the particles in its path is called Tyndall effect. The Tyndall effect can be observed in the case of the canopy of a dense forest, and also when the white light that enters the room through the window. In such common cases, you can observe the same Tyndall effect. So these are the ideas regarding the scattering of light. Clear? Okay. Thank you for watching video.